I chose this one because it has the mixture of sine squared and cosine squared, and I know that during the week we discussed talking about changing the whole thing to one trig identity. So we would either change the sine squared to a cosine or a cosine squared to a sine. And I can do that in one of two ways. I could switch it out just straightforward, and it gets a little complicated, but I want to show you a tip or a way that you can look for things, and maybe this will make your situation a little bit easier. Well, I see 3 sine squared x plus 2 cosine squared x minus 2. It makes me think, oh, I should factor that, but I wouldn't really need to do that unless I've already got it into the same sine or cosine, but I don't. I look at this and I think, the second part is almost like cosine squared minus 1. I really wish it were that because I know a really easy substitution for that. Okay, then I think, okay, well, I could actually factor out just of the last two pieces. I could factor out the 2. If I factor out the 2, or a negative 2, whichever way you want to do it, I just factored out a 2, and I'll get this, right? Okay, if I factor out the 2, I just pull it out of the front part, or the last two pieces, and I get cosine squared x minus 1 left over. Well, if you look at your trig identities, if you rearrange your original Pythagorean identity so that it's cosine squared x minus 1, it's going to be equal to negative sine squared x. And so we're going to make that substitution. I like that substitution because that's the same unit as my first term. It's already a sine squared x. So this is simply going to be subtracting one of those sine squared x's. Okay. We're going ahead and substitute that in. Be very careful. This one, the negative sign can cause a problem. If you leave the negative sign out, then you're going to get the wrong answer. It is negative sine squared x, so I plug in the negative sine squared x. And we're going to distribute that 2 inside of it, so we're going to get this. 3 sine squared x minus 2 sine squared x. And so the 2 just multiplies times the negative sine squared, and you're going to get this. And this is actually the easy part. 3 minus 2 is 1, so if I have 3 sine squared x's minus 2 sine squared x's, then it only leaves me with 1, and that's my final answer. 1 sine squared x, or just plain sine squared x. Not the most difficult one in the world, but if you're not sure where to start, this can be very frustrating. Okay. Now, granted, I believe that you could do this one a number of different ways. Some of you may have said, I'm going to change sine squared into 1 minus cosine squared, or you're going to change cosine squared into 1 minus sine squared, and you could have proceeded in the same way. Okay, I think this was maybe a quicker way, but it's not a big deal. You will still end up with sine squared x